Hello again and welcome to episode 21 of Simply Electronics Basics. Today we're going to have a look at inductors, what inductors are, and the basic principles of inductance itself. Now some of you may know that when you pass current through a coil of wire, this generates a magnetic field around that coil. The opposite is also true. If you pass a magnet through a coil of wire, this will induce a current that flows through the coil. If you understand this, then you should be able to understand the basics of inductors. This circuit on screen has a really useful purpose, but I'm not going to focus entirely on this circuit because I don't want to overcomplicate things in one video. So make sure you are subscribed to get notified of the next video, which will be about this circuit. So as we're going to focus on the inductor, and you now know one of the basic principles of Faraday's law, when passing a current through a coil, you induce a magnetic field, and when passing a magnet through a coil, you induce an electrical current through that coil. So this circuit is quite a simple circuit, but more complex than we've covered before. I have a 10 volt DC power supply. The current is flowing through a coil, and then flows through a switch. Now this type of switch is a MOSFET transistor, but don't worry about that for the moment. Just pretend that this is a normal on-off switch. Accept the fact that we are electronically controlling it to switch it on and off very fast. So we have the power supply running through an inductor. Obviously the current is only able to travel through this switch when the switch is on. When the switch is on, the current flows from the inductor through the switch and to this power supply. Okay, so we understand this part of the circuit. You can see on the other side here, I also have a diode and a capacitor, but we'll get to that shortly. Because I'm passing a current through this inductor, which is essentially a coil of wire, as we stated before, a current passing through a coil of wire induces a magnetic field around the inductor. Now, we have this switch turning on and off every second. This means that current is only allowed to flow through the switch every second. What you need to understand is that because we've passed current through this inductor, it now has a magnetic field surrounding it. This inductor naturally wants to get rid of its magnetic field when there is no other current flowing through it. As the magnetic field around the inductor collapses, this causes some current to flow through the inductor. So the current flowing through the inductor, when the magnetic field collapses, is coming from the magnetic field, not from this power supply. So when we turn this switch off, and there is a magnetic field surrounding this conductor, the magnetic field starts to collapse, and therefore current starts to pass through it. Now because this switch is off at the time this magnetic field is collapsing, current is not flowing through this switch, but instead it flows through this diode and capacitor arrangement. For now, that's all you really need to know about the capacitor and diode. It's just another path for the current from the collapsing magnetic field to flow through when this switch is off. You can see on the top of the screen here, I have a graph. This graph shows the current flow through the inductor. You can see that when the switch is turned on, current increases across the inductor, and when the switch turns off, the current does not instantly go to zero. It slowly fades away as the magnetic field collapses. So when the switch is turned off, current still flows for a short period of time. So this entire circuit actually works to do something really amazing. But to keep things simple, I'll leave this circuit for the next video. So make sure you are subscribed to this channel to get notified of the next video. Leave your comments below if you have any questions, and give the video a thumbs up if you enjoyed it.